Hello, my name is Roderick L. Roll, and today I will be talking to you about the atomic structure. Chemical bonds are formed using the electrons in the outermost energy shell. So in this image below, we have several atoms or several elements. Let's look at carbon. Carbon has a valence of 4. This means it has a bonding capacity of 4. It also has a valence electron of 4. This means it has 4 electrons in its outer shell. It also has a valence shell of 2. We are going to go over all of those terms now. Valence shell is the outermost energy level containing chemically active electrons. So we'll first look at carbon. If you start from the nuclear core and count outwards, carbon has 2 shells. It has an inner shell and an outer shell. The outer shell is number 2. So the answer in reference to the valence shell, the answer would be 2. Nitrogen, the answer would be 2. Oxygen, the answer would be 2. Phosphorus, the answer would be 3. So phosphorus has 3 shells. The outermost shell contains electrons. So the answer would be 3. So previously, you could have drawn a planetary model to decipher what the valence shell was. You could also just use the periodic chart. On the periodic chart, you have numbers to the far left. Those numbers represent the outermost shell. So we said carbon was 2. You find the C for carbon. You follow it over and see what row it is in. It is in row 2. We also looked at nitrogen. It's in row 2. We also looked at oxygen. It's in row 2. And then we looked at phosphorus, the P. The P is right below nitrogen. It is in row 3. So you can draw the planetary model, or you can just use the numbers to the extreme left of the periodic chart. The next term you will learn is valence electrons. These are the electrons that are located in the outermost shell of that element. So carbon has 1, 2, 3, 4 electrons in its outer shell. So therefore the valence electron would be 4. Sulfur has 1, 2, 3, 4, 5, 6. So the valence electron for sulfur would be 6. Another way of performing this task, instead of drawing the planetary model, is to just look at the extreme top of the periodic chart. This is referred to as the column. So we looked at carbon. It is in Roman numeral 4 column. So that is 4. It has 4 electrons in its outer shell. And then we also looked at sulfur. Sulfur is in column number 6, so it would have 6 electrons in its outermost shell. The third term we will learn is valence. This is the bonding capacity for that element. So to figure this out, you have to use the octet rule. You take 8 and minus it by the valence electron. So for example, oxygen has an octet rule of 8, and it has 6 electrons in its outermost shell. So 8 minus 6 equals 2. So its bonding capacity is 2. Octet rule can be used for all shells except the first. The first shell can only hold up to 2 electrons. All others will hold 8. Elements in group 1 through group 7, or in column 1 through column 7 react with other elements by forming ionic bonds or covalent bonds. They are all trying to achieve the noble gas arrangement. The noble gases are the column to the far right of the periodic chart. So usually 8 electrons will be in this outer shell. So let's look at the capacity of some electron shells of atoms. Shell 1 holds up to 2 electrons. Shell 2 can hold up to 8. Shell 3 can hold up to 18, and shell 4 can hold up to 32. So shell 1 holds up to 2 electrons. How we write it is we write it as 1s. Shell 1 has a spherical shape. So in the image to the far right on the bottom, you see 1s. You would put 2 dots right beside 1s. The second shell holds up to 8 electrons. We call this 2s and 2p. Look to the far right, the bottom again. You put 2 electrons right beside 2s. And then when you go to the next row, where the 2p is, you would start with one line, put a dot, go to the next line, put a dot, go to the third line and put a dot, then come back to the first line and fill that orbit, go to the middle one, fill that orbit, and go to the next one. Then, if you still have electrons, you would go to the third shell. So the third shell holds up to 16. Those spots or those orbits are 3s, 3p, and 3d. And then shell 4 will hold 32 electrons. 4s, 4p, 4d, and 4f. Shell 3 initially takes 8 electrons, then it will stop filling for a moment. At this point, shell 4 takes the next 2. This is denoted in the image below. After you fill up 3s, you go to 3p. You start by filling the first line, put a dot, the middle line, put a dot, and the far left line, put a dot. You go back to the first line, fill that orbit, go to the middle line, fill that orbit, and go to the last line and fill the orbit. If you still have electrons, you go to the next shell, not to 3d. The next shell is 4s. So that's what it means when it says the remaining shells will hold 8. But technically, some of them hold more than that. Why? Initially, as we're adding electrons, once we get to 8, it stops filling momentarily in that shell, and the next electrons will go to the next shell. This break in filling is due to an overlap in the energy value of shell 3 and 4. Now, I want you to do this activity. I want you to tell me what is the valence shell of carbon, valence electron of carbon, and valence of carbon. After you have figured out those answers, do oxygen, hydrogen, and nitrogen. Pause the video if you haven't figured out the answers. This is the answers to the question I just asked. Each shell contains orbits. I mentioned this in a few slides before. We're going to now look at an orbit. This is where the electrons spend 90% of their time in an orbit. 2 electrons can occupy an orbit. 1 can be there, but 2 is the maximum number that can exist or reside in that space. So I'm going to now show you how to draw that image on the bottom. Shell 1 has 1 orbit, and it is called 1s. It is a small spherical orbit. This is a space where the electrons spend 90% of their time. Shell 2 has 4 orbits. They are called 2s and 2p. The 2s is a spherical orbit also. 2p actually is composed of 3 dumbbells. This image is illustrating how it looks. Shell 1 has a small spherical orbit. Shell 2 has a larger spherical orbit and 3 dumbbells. Let's look at the x-axis. The x-axis shows a figure 8 on that x line. Then we have the y line. That's another figure 8. That's where 2 electrons will spend 90% of their time. The final one is the z-axis. That's where the other 2 electrons will spend 90% of their time. If you superimpose all of these images, you get the one to the far right. Instead of drawing that image, we're going to draw the planetary model. So in this image to the far right, that is the planetary model. That is how you will draw it on the exam. You would draw your nuclear core. The first shell, you will put 2 electrons side by side. The second shell, you'll put 2 electrons at 12 o'clock, 6 o'clock, 3 o'clock, and 9 o'clock. Inert elements have their outermost energy level fully occupied by electrons. These inert elements are to the far right of the periodic chart. We call them noble gases. We have 2 examples in this image: helium versus neon. So again, on the periodic chart, on the far extreme right would be your noble gases, or chemically inert. They do not need to link up with any other element because their outer electron shells are full. So let's look at reactivity. Why do some elements want to link up? Their outermost shell is not full. So hydrogen has 1 electron and it needs 1 more to be satisfied. So it will tend to want to link up with other elements. Carbon has 4 electrons in its outer shell. So it has a valence of 4, or a bonding capacity of 4. So it will want to link up with 4 elements. So everything to the left of the noble gases are reactive elements. At this time, I would like for you to draw the planetary model for the following atoms. Pause the video if you are not ready to proceed. Lithium, you should have started with a nuclear core and put P equals 3 and N equals 3.9. Then you would have drawn 1 shell. You would then put 2 electrons in that shell. Then you would go and draw another shell, shell 2, but only put 1 electron in that shell. So make sure you drew each of these atoms correctly.